going to have 1 million bacteria, maybe more, because they start growing on resources that we put together. What if we've got enough of that high nitrogen material that every single bacterium, 600 million bacteria per gram of our starting organic temperature in that compost pile, from whatever your ambient conditions are, to 160 in a couple hours. How much party food are you going to put into your compost pile? Because if you put too much, you're going to go very anaerobic very rapidly, and if those microorganisms grow so fast that they use up the oxygen faster than the oxygen can diffuse into that pile, it's going to go anaerobic. As soon as we go anaerobic, those anaerobic bacteria, fungi, the yeasts, start making alcohol. And what is the heat of combustion of alcohol? It's 180 degrees. So if your organisms grow so fast, if you put too much high nitrogen in there, too much party food, this party's going to get out of hand. And your whole pile's going to heat up, oxygen's depleted, start producing alcohol, you get a temperature of 180 degrees, and your whole entire pile's going to go boom! Burst into flame. Break windows in everybody's houses surrounding you. So let's not do that. We want to be real careful about the amount of high nitrogen we're putting into that pile. We do not want it going anaerobic. We do not want to reach a temperature of 180 degrees. So a little testing with your high nitrogen. Real important to do right off the bat. So that's high nitrogen. So remember, when that first flush of plant growth starts, grass, or when you're looking at your trees, that first set of leaves that start to be produced as you come out of a dormant period could be really high in nitrogen. Look out. When you're dealing with any leguminous material, legumes, invariably, as long as they've got good nitrogen fixing going on in the root system, they're going to be high nitrogen. The leaf material on your tree is going to be high nitrogen. So be aware of how much high nitrogen you're putting into the pile. Now, as that plant starts to grow, all that highly concentrated mineral material in that leaf is going to be diluted as photosynthesis starts to occur. As that grass starts growing taller, the sugars we're making with photosynthesis dilute the nitrogen, phosphorus, sulfur, magnesium, calcium, acid, blah, 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 blah. So now, seed-in ratio, after that first flush of growth, after the first leaves come out, now that seed-in ratio is going to be 30 to 1. That is bacteria. So that's what supports and sustains our bacteria. So some portion of our compost pile needs to be bacteria food, because we need those to form structure, to protect our root systems. The third component that we want to have are those foods that grow fungi. So this plant, as it's been growing, it's diluted the nutrients. It's still getting more nutrients from that soil, supplying that plant so it can grow as much as it can. And once that plant has all the nutrients that it needs to go into reproductive mode, that's what it's going to do. Seed-in ratio on the flowers. Seed-in ratio on the seeds of your grass. When you're looking at the fruits on your trees, seed-in ratio of the seed inside any of your fruits. What is that? You guys grow plants? And it's just something that no one's ever told you before, because we don't care about these things, but we should. When we're looking at flowers, when we're looking at seeds, the carbon and nitrogen ratio of that material is 10 to 1. It's just like manure. It's just like any legume. So your plant, if it's not being given all the nutrient it needs really fast, really quickly, if it's not getting adequate, it's going to steal from the other parts of the plant, take that nitrogen, phosphorus, sulfur, magnesium, calcium, and put it into the seed. Because what does that plant care about? Reproduction. Next generation. Everything is for that next generation. So it may well be taking those nutrients out of the rest of the plant. So the seed-in ratio on what used to be 30 to 1 is now 60 to 1, maybe 100 to 1. It's starting to go in the direction of fungal food. So when that plant starts to blossom, when it starts to go into seed production, we're dropping the carbon and nitrogen ratio, and we're making it kind of intermediate bacteria fungal food. So now that seed is set, the plant disperses its seed, and now the plant says, whoops, dry season's coming. I better take any nutrients I've got left in my foliage and pump that back down into the soil, store it in my root system. So when temperatures, moisture become good again, now I'll be able to regrow. So any of that standing dead above ground is now fungal food, because all the nutrients that that plant can possibly take out are now down in the root system of the plant. So when we're looking at standing dead grass, dormant, standing dead, it's fungal food. Seed-end ratio, 150 to 200 to 1. When your tree decides to go dormant and it pulls the nutrients out of the leaves, so there's no nutrients left in that leaf material, and that leaf falls off your tree and comes down to the ground, seed-end ratio, that leaf material is probably 250 to 300 carbons for every nitrogen. In the bark, in the wood of your tree, carbon and nitrogen ratio, 300 to 500 to 1. These are all fungal foods. Lots of cellulose, lots of lignin, lots of really gnarly, good fungal foods. I'll explain exactly why that is a bit more once we get back into our discussion. But we want to be grown fungi, we want to be grown bacteria, and we got to have some party food to make them get the temperature built up so we kill the human pathogens, the plant pathogens, the root-feeding nematodes. All the bad guys have to be done away with, and so the seeds, we have to make sure the temperature in that pile gets up, but we don't want to get to be too high. Goldilocks principle, we're going to have to control these recipes carefully. So, when we come around here and...
Come this side so you can explain on this side. You can tell me what you want us to do.
So you can see where that manure is already mixed with some woody material. So exactly what is the balance of high nitrogen to wood in there? High nitrogen to fungal foods? We don't know, and that's where figuring that out is what we got to monitor when we start testing temperature in these piles. So typical recipe that we would start out with would be maybe 40% woody, 35% green. And what is that? That's now 75%, so 25% high nitrogen, except some of this is woody. So we're going to have a little bit of woody in there. What do you suppose that ratio is? Anyone want to eyeball it for me? It's always up in the air. 50-50?
Manure and straw? It's maybe, yeah,
60 manure, 40 straw.
So that 25% of our pile is actually about half of it is going to be woody material. So then that ups this from 40% to maybe 50% woody, 30% green, 10% high nitrogen, something like that. So now we'll put this together and find out what happens with the temperature.
Because some of the grass is still green and it's not completely dry, would it then have higher nitrogen?
Nope.
No,
because we're presuming that that grass is way beyond the first flush of growth, because it was cut and dry. Now, if that grass had been sitting, gone through flowering, produced its seeds, and now we went out and dealt with it, it would probably actually be woody component. But you can see where most of it was actually cut green. It's dried a little bit because it's been out in the sun, but it was cut green. So it's bacteria food. So,
so we can measure it with that if you want.
okay. Yeah, somebody other than me gets to scoop. I'm a lazy gardener.
So you said, Elaine, did you say you want 40% woody, 35% green?
Yeah.
Or you're just guessing?
Yeah, it's a good ratio. So,
And then what's the other 25%?
high nitrogen. Okay. Except that some of our high nitrogen is actually going to be woody.
1.
What was the percentage?
So we have one scoop.
5%.
Nah, don't have 5%. So there's one scoop. Let's hope we can get 4 scoops out of this.
4 scoops.
But, you know, we might only maybe able to make 3. So that we just adjust the components of everything else, because the woody is probably our limiting component.
But we got extra woody in there, right?
Yeah. So our manure is going to come with some woody. So there's 2. I notice here I'm not going to worry so much that you have the right volume, end volume, because we're in the tropics and it never gets cold here, right? So we don't have to worry about freezing temperatures, shutting down our microorganisms. In the temperate climate, you would always have to make your compost pile at least 3 foot tall, 3 foot wide, or you lose heat in the middle of the night.
67 degrees.
Yeah,
It's cold for us.
Yeah. Let me tell you about minus 72. Minnesota, it gets that cold. We all go outside with our squirt guns because we like to shoot each other with ice pellets. We are really nice.
What is that? Is that 3 or 4?
This is the 3rd one.
So, if we think we have woody material, could we reduce our woody material and increase our...
This is like 3.5 woody is what this is going to turn out to be.
Yeah.
So now if that's about 40% of our pile, now we want 30. How many scoops full of that do we need?
Don't we want to layer it?
2 to 3.5.
About 3.
Yeah, about 3.
Don't we want to layer each type in there instead of having to try to get a pile of
Well,
one and a pile of...
I like to stick it and then return it. Because notice that this is not up to moisture.
What did you say?
This is not up to moisture level. So we need this about 50%.
So we went about, it'll be about 4 because someone's heating, yeah?
We'll figure this is about 4. The woody material that's going to come in with the manure.
Yeah,
If you get it so hot, you're killing the bad ones. Aren't you also killing the good ones?
Now, is a wonderful factor that the good guys are much more resistant to high temperatures. They go dormant, but they aren't
You know
killed.
what, Chris, we can,
nice
I
of
think, so we can
Spread it
mix
out.
easier. Maybe we should take out the other, that can come down too.
Take this one off too.
Maybe, what do you think?
Okay, yeah.
And it's easier for us to mix.
Moisture. That's what we're going to run it. It's way too difficult to really get after this from a weight point of view because what's the moisture of this grass? Yeah. It's, you know, we're up there around, we're probably 35-40% moisture on the grass. That woody material, pretty dry.
And using a compost thermometer?
Yeah. And these guys just ordered a compost thermometer this morning.
I was going to say, I checked the 10 places.
I'll bring one tomorrow.
I had to order one online. Garden Exchange carries them, but they were out for months. So, they're
Yeah,
not
where'd
easy
you
to
get our...
I usually go straight to Rio Temp, R-E-O-T-E-M-P. And those are stainless steel. They're ordered the one that's about 4 foot long. Comes with a nice page on the top. Really easy to see for those of us whose eyes are starting to fail. Big letters. And once we get this pile together, the hottest part of the pile is going to be, make our pile like that. The hottest part of the pile is not right down on the surface of the soil. It's up a little bit. The soil is cooler than the temperatures we're going to have in the pile. So when we're taking the temperatures, we want to aim towards that hot part of the pile because we want to know that the center is getting up to heat for long enough. We've got to be over 131 degrees Fahrenheit for 3 days to kill all the plant pathogens, human pathogens, root-feeding nematodes, and weeds. But if we get up to 150 for 2 days, we're going to kill everything. If we can get it to 160 for 24 hours, we're going to kill the bad guys. So really the center of that pile, you got to be tense and making sure how long it's been at one temperature. And so now can we turn? Because now we got to get the outside part of that pile into the center. The center part of the pile has to get on the outside. With one turn, are we going to know for absolute sure that we've gotten everything into the middle of the pile and got it? Yeah, so we want to be turning it The recommended number of turns is 5.
Oh my.
So you want your temperature to stay above 131 for the full 5 days, but that's the temperature in the middle
5
of
days
the
of
pile.
turning.
5 day,
5 times.
5 times turning, right.
3 days, 5 times over.
Well, the
It has to
length
be
of
up to
time that
temperature.
you've got to be up above 131 is 10 to 15 days. So during that 10 to 15 days, you're going to be turning 5 times.
Well, Dr. Cho wants you to keep it 130 to 140 because I don't know why, but that's what he wants. I had a lot of trouble keeping it that low.
Yeah,
I
and
was constantly coming out and spreading it out and, trying to, it just wanted to keep going up.
and I just don't worry
Yeah.
about it. If it goes over 140, you're not killing any of the good guys.
Good.
They're just going dormant. Yeah, you're killing the human pathogens, plant pathogens, and why should these things be so susceptible to heat? I don't know. I don't really care. Thank you, God. It works.
So you would kill E. coli if you had stool in there. I mean,
Yep.
when-
If you put any manure in there, well, we're putting manure in there.
Yeah.
So there's a boatload of E. coli in there. There's other human pathogens in that manure. Mm-hmm. Yep.
How long can the E. coli stay dormant if it doesn't get up to the temperature?
E. coli does not have a dormant stage. It doesn't produce a cyst. It does not produce a spore. So heat is going to kill it quite rapidly.
But I mean, how long will it live if it doesn't get up to temperature? Can it stay indefinitely?
The E. coli will start to grow again. It can start to grow as soon as the temperature in your pile drops below 131. You want to make sure that the center of the pile gets up above 131 long enough, or above 150 long enough, or above 160 long enough. And then we turn the pile, so now this outside stuff where there still may be E. coli gets into the center. And now we keep that at high enough temperature. So if it's only getting up to 135, 140, you're going to have to leave it 3 days before you can turn it. But if you can get the center up to 150, then you can turn at 2 days. If you can get the center of that pile up to 160, then you're going to be able to turn after 24 hours. So do we really have to have the temperature above 131 for 10 to 15 days? Well, if we were really good at this, we probably wouldn't have to follow those regs. But that's what organic regs are. That's what most composting regulations in most states in the U.S. That's what it is.
Can you get it too hot for too long?
Yeah.
And then kill off the fungi that way?
Yeah, you can because it's not really temperature that kills our beneficial organisms, it's lack of oxygen. So if you get up above 165, turn the pile if it gets too hot. It doesn't matter. Maybe you haven't let it be above 160 long enough, but if it's hitting 165 and you're going towards anaerobic conditions, you are killing all the beneficials. So turn it.
For organic certification of your compost, obviously there's key standards and procedures. What about the ingredients? What happens when you take food waste and it's a restaurant that has GMO stockings and all kinds of stuff? How do people approach that?
The attitude in the organic world is that by going through the composting process, we are taking care of all of that GMO material. We are destroying most of that DNA sequence that could be a problem. So most of the data that's been done on that says that that isn't indeed the case. There is one paper that says it didn't fix the problem, but they have no data on their temperature, they have no data on their moisture levels, they have no data on their starting materials. So were they really composting correctly? Probably not.
So what are some of the ingredients that you have in organic compost?
So now we water it.
Plastic.
Plastic, any type of toxins, right?
Yep, so as he's turning it, let's just keep spraying that water.
You want to be the water regulator?
I'll be the water regulator. Oh, I can do this. If you don't work fast enough. The watering will often cool temperature right down, but when you put too much water in there, you're going to be restricting the ability of the oxygen to move into the pile. So it's really not the preferred way to control temperature. Just by turning, you will drop the temperature of the pile by about 15 degrees. Yep. Yeah, your microorganisms don't like you a lot. If you let this get below 30%, they'll start to go on straight.
That's real dry.
Yeah. Right. You know, I would even say that chicken litter was probably down around 10%. So it's good mixing. See how I'm trying to get it where they're flying this stuff through the air is where I'm really trying to wet it down, because as material is moving through the air is much more likely I'm going to coat all of that material with water. Let it soak in. I don't want it to ball up. All these good things you want to think about. I think this corner right here needs a
Got it, boss.
Woohoo! Almost gotcha.
Hey, it's okay.
We're gonna have a probe on this tomorrow.
Yeah, I'll bring a thermometer tomorrow.
Maybe do you want someone to spill you?
Huh?
Want someone to take a turn?
Yeah.
And it would be a good idea, you know, like after you've got the amounts of these materials, take really dry material and put it into your little, you know, wading pool, wet it up, so it's going into the pile already up to 50% moisture.
You misunderstood me. I was thinking of a bedding pool. Who can guess the temperature tomorrow at noon?
It takes a
The
few
beer
days
is
to get to
what
130,
the
right?
currency is in this
It takes a few days to get to 130, right?
Not necessarily. Depends on how juiced, how much this party food you put in
How
here.
much fuel and how much oxygen, right?
Mhm.
Yeah, okay.
So how much high nitrogen was that chicken manure actually? Because I've seen piles go from ambient temperatures to 180 within 5 or 6 hours.
Like what? Like mill run or something, or
It was just really
Beer mash?
juicy.
What if you
Beer mash doesn't
only
have
what if you
lemon.
only had carbs in here? Would you be limiting the kind of
You would never see the temperature get up to even 131.
now? Would you be limiting the types of organisms that could grow too?
If you only have one kind of food resource in here, yeah, you don't get the diversity. So notice that we want a good mixture of different kinds of materials.
is there any point in testing the organisms already on the materials you're putting in?
We just should have a whole bunch of different kinds of species and everything. So, you know, again, if you're getting materials from conventional systems that have been treated with a lot of pesticides and inorganic fertilizers, you're not going to have diversity. So this, I want to turn this off.
So if you got a compost source that's even been exposed to fertilizer,
Chemicals.
then
Now,
chemical.
What I want to do is reach into the pile and kind of get an idea of, is this wet enough? So I'm just going to grab a handful. It's going to fit in my hand pretty well. And now I want to be able to look at what's coming between my fingers. Is this wet enough? There is a little bit of water, a little bit of moisture coming through my fingers. So that's enough. I don't want to get it too wet. So I may go down in here and take a handful from down in there and see, is the whole pile wet enough? So, I want to be able to see between my fingers. Is that wet enough? So the bottom's really quite a bit wetter. So let's turn it a little bit more to get that drier top.
Where do kitchen scraps fall in the range of the
Kitchen
types of material?
scraps, typically if it's vegetable material, it's going to be green. If it's meat, cheese, things like that, then it's going to be high nitrogen.
organically grown food, would this be considered organic?
Yeah, because once it's gone through the
through it.
composting process, then we consider that organic. We can resuscitate anything. The problem when you get chicken manure that's been fed pelletized material is that is typically extremely high in salt. And you can shut down everything going on in your compost pile by having too much salt in here. So you put a pile together like this, and you should have really good manure in there, lots of hearty food for my bacteria and fungi. This temperature should be rising. It should be, you know, with this mix, probably we're looking at, I'd expect 100 degrees tomorrow, maybe 110 degrees. The next day, up at 130. But what if we come here tomorrow and it's at ambient temperature? Well, then let's look at moisture, let's look at some other things. But it could be that the chickens were fed pelletized material and high salt.
This is a large fungal body.
So there's a stage when you're making
That's all
Straw
dry,
mat.
dry right there. Can you get a little bit of water on it?
Elaine, there's a stage when you're making, I think it's IMO4, that you put seawater in, which obviously has salt. That's when my pile heated up the worst when I put the salt, that seawater. Do you ever recommend
diluted, right?
using, yeah, it's diluted, of course, but do you ever recommend using
And what I would suspect is
Humic acid.
water in there. And that's what was limiting the growth. It was probably a little dry. We're putting a good mix of organic matter like this. I have never seen a... But on the other hand, I've never really tested salt water to see if it's really working. Yeah, so make a pile with that you don't put the salt water in, and make a pile where you do. Yeah. And then you compare what's your pile.
And you referenced that there could be degrees of humic acid in seawater.
No,
No.
no humic acid in seawater, unless you've got sediment material.
What is interesting in Hawaii is that a lot of the meadows that are exposed to the ocean mist sprays are a lot greener.
Now, is it because
Some of your
we've
best
had,
pasture land.
have they been putting a lot of pesticides on, killing all the
It's just all
biology,
over
so everything's
each one of the
leached?
islands.
See, so there's some research that needs to be done. We really need to understand.
How ocean mist can affect the
And
it changes the pH.
so all of those things would have to be part of that trial.
Typically, your ranchers notice that best pasture is closest to the
I know that, like in California, things that are close to the ocean get more of the mists and fog, and so they're way more protected. But it's not salt spray.
Those salt sprays go pretty far too. That.
Yeah, they can. Yeah, absolutely.
Especially if you have electronics in your house.
Yeah. You notice it right away.
Yeah.
Or anything metal.
All right.
How many
There we
stainless
are.
steel
Think it's
fridges in
mixed
Hawaii?
enough? I think that's looking pretty good.
See, it's mixing up.
Now, how tall should we spread it out a little?
I would leave it in a pile like that. So
Leave
we
it
have
like
something to go into the middle.
Cover
and
it.
measure
Cover it.
Yeah, let's cover it because we really do not need it down for it to totally saturate our compost.